This is video 1.2.2. It's completing the square again, so we're going to continue to learn how to complete the square, but we're going to jump in at a little higher level in this video. So we're going to add one more step on to what you've already been doing in class. So the first example, y equals 3x squared minus 6x minus 5. And this example is different because of the fact that you have a 3 in front of the x squared. And so our first step that we're going to add in is that our first goal is to factor out the 3. So we're going to start by rewriting this as 3 times x squared minus 2x minus 5. Okay? So we have this started, and this is where it's going to get a little bit tricky, but we're going to keep with our process. But our factoring, what we're going to end up factoring is this piece right here is what we're going to create the perfect square with. The 3 will impact things a little bit later on. But notice how these two expressions right now are equivalent. The first and the second equations are equal. So that's the number one thing I want you to notice right now is that they are equivalent. So we haven't changed the value, and that's our number one goal, is to not change the value. So what I'm going to do is I'm going to think of this 3 out here times this perfect square. So remember, this perfect square is, to complete this square, we're going to draw a generic rectangle, and we're going to put our x squared in, and we're going to split our two x's up evenly. Okay? And I have that 3 there because remember, this perfect square is inside of and being multiplied by 3. Okay? It's one of the factors in that part, 3 times something minus 5. And then that minus 5, I'm just going to drop it down. So just kind of like we've been doing in the previous video. So now, I'm going to finish completing this square. So I'm going to go back to my inside piece here and finish this square. So we have x minus 1 times x minus 1. And then we see that that creates a positive 1 right there. So typically at this point, now I don't want you to do this, but typically at this point we would create a minus 1 on the outside. Okay, but here's where this is different. Because this minus 1 is actually being impacted by the 3 right here. Okay? It's actually 3 times bigger than that. So instead of just minusing 1, we actually have to minus 3 because of that 3 on the outside. So don't lose that 3, that original factor that we factored out, that we saw up in here. Okay? Don't lose that 3 right there, because that is important to the actual value that's on the inside there. So what we're saying here is that 3 times x minus 1 squared minus 8 is the same as my original problem. So the minus 8, remember, we get that by simplifying the minus 5 and the minus 3. Okay? So that's really important that you not forget that that 3 actually makes this 1 3 times bigger. So let's try this again. So we're going to look at 3 examples in this video today. So the second example, so now we have a 2 minus 8x, 2x squared minus 8x. So again, we're going to start by factoring out the 2. You have to factor it out completely. Even if it didn't go into the 8 nicely, we'd have to factor it out completely. So now we're going to, remember, we're focusing on this piece right here. We're going to complete the square there, but we have 2 times that perfect square, whatever it ends up being. Put the x squared in, split the 4 x's up evenly into negative 2x, negative 2x. Okay, the plus 3 simply drops down from here. And now we're ready to complete the square. So inside the perfect square, it looks like, since these sides are x minus 2 on both sides, perfect square, of course, same size. The inside is 4. So now we're going to think about what we have to add on to offset this 4. But remember, it's not just 4, it's actually 2 times 4, because that whole piece is being doubled. So it's going to be 8. So we're going to subtract off 8 on the outside. Okay. So my completed square form is 2 times x minus 2 squared. And then I simplify this piece here, and I get a minus 5. And that is an equivalent expression to the original problem. In this third example, you'll notice it looks a little bit different. It's missing a piece, and so we'll talk about how to deal with that, and there's some other things that could pop up because of the -5 in the front there. But remember, when you're missing something, you can always add a +0 on the outside to kind of show that there's something that usually is there. So we have that if you want it. Otherwise, most things will stay the same, but what's going to be key here is that to start, I'm actually going to factor out a -5 from each of the terms. I have to get it to be a constant of a 1x squared, not a -1 or a -2 or something. It has to be exactly 1. And so that would make a -2x in order to get the positive 10x on the inside. And then +0, of course. So again, we're going to do the same thing, -5 times the generic rectangle. That's going to start with x squared. And we'll split the -2x into two corners, so -1 in both corners. So we have x minus 1, x minus 1. So before I continue, I should add that +0 on the outside. And let's see, what we create on the inside here is a +1. Remember, it's not really what I put on the board, though, because it is being impacted by this -5. So it really creates a -5. To cancel that off, I need to put a +5. So remember, the whole goal is to cancel it off. So it actually makes a 0 in the end. And we end up with a completed square of -5 times x minus 1 squared plus 5. That simplifies to +5. And there's your equivalent expression. That is the same exact equation as the original. So, one quick reminder, if you ever want to check your work, it's as simple as doing a little bit of multiplying out. So it's as simple as multiplying out x minus 1 squared, and we would get x squared minus 2x plus 1. And we'd still have this +5 on the outside from up here. And then we keep going and we multiply further and multiply out the -5. And we get -5x squared plus 10x. And then -5, and we'd still have the +5. And what I want you to notice is that this expression here will simplify to -5x squared plus 10x, which is, like we said, equivalent, shows that it's equivalent to this one up here. So there's a beautiful way to check your work. It's just going back and redoing all the hard work you just did and multiplying it out. So definitely feel free to check your work on any type of problem. So your checkpoint, give it your best shot. Try to follow the steps. Think carefully on each step. Feel free to watch the video again. It's there for you whenever you need it. Bring your questions into class so we can go over them and talk about these checkpoints, but you must attempt it on your own.